Muri, Mura and Muda. 3 magic wands of Japanese management system. The 3 Japanese mantras of Muri, Mura and Muda, known as 3M practice, is an integral part Japanese manufacturing system. The 3M practice brought down the cost of production to bare minimum without affecting the quality or user-friendliness of the product. The effective elimination of Muda or wastage is immediately experienced and the results are visible. The impact of Mura and Muri are subtle and not visible but equally significant in attaining the end objective of customer satisfaction and cost reduction. Muri. The word Muri means unreasonable or irrational approach to any field of operation. Muri looks for irrationality with 4 major approaches. A. Things or activities that are extremely difficult to do and at the moment beyond the reach should be identified and eliminated from our activities, as there is no meaning behind pursuing these activities and currently beyond the individual's or organization's capability. B. There is futility in pursuing and doing activities that do not make much sense or it is difficult to find reasons for. C. Eliminate the activities that are done because you are told to do so without understanding the reason for doing the same or its underlying benefits from performing such activities. D. Eliminate irrational actions or operations that cause undue or excessive fatigue due to a lot of physical effort, frequent stress to body movement, mental fatigue due to unwarranted workplace stress, remembering a lot of things, worrying about defects or breakdowns, struggling to read illegible words and symbols, etc. Application of Muri case study. A case of Japanese automobile and machine tool industry. American and European car and machine tool industry designed a car or two-wheeler or a machine tool to last for next 20 to 30 years and to give consistent performance. Therefore, they multiplied the calculated dimensions by the factor of safety of 2. This led to increasing dimensions of the components. Therefore, the cost of raw materials was double, the weight of the automobile or machine tool was heavier and less flexible and difficult to handle. As per the thumb rule, half of the cost of automobile or a machine tool consists of raw materials, and if it doubles, the price of the final product also nearly doubles, as all other costs are directly or indirectly related to the processing of raw material. The Japanese thought differently, and rationally with customer orientation. Thus, Japanese designed a car or two-wheeler for 5 years because that is normally the lifespan for which the product is effectively used. Therefore, Japanese used a factor of safety of 1.25 instead of 2. Their raw material cost was about 62.5% of the Western design. The end product was identical in terms of product features and user-friendliness. The price of the end product was proportionately lower by almost 30% to 35%. The automobiles were also lighter in weight due to lower percentage of the raw material used. This led to the reduction of dead weight to be carried by the vehicle, thereby increasing the pickup of the vehicle as well as reduction in fuel consumption. The end result of practicing Muri was a better performing product which is more user-friendly and priced much lower than conventional Western products. 2. Mura. The Japanese word Mura means irregular, uneven or inconsistent. Either due to lack of interest or over-enthusiasm, we tend to deviate from the laid-out standards, leading to inconsistent actions. Such inconsistencies can lead to irrationality and waste. Bottleneck theory or theory of constraints originate from the principle of Mura. The bottleneck theory states that the neck of a bottle or the least diameter of a bottle decides the rate of flow out of the bottle. When applied to industry, this theory states that the department in manufacturing chain with least capacity decides the plant capacity. The corrective action is strengthening this weak department by increasing its capacity by minimum investment. The result will be quantum jump in overall performance of organization, as the extra capacity is already lying unutilized in other areas. Goldrat's theory of constraints also tends to be developed around the same principle of Mura. The theory states the weakest link in a chain decides the weight that can be lifted by the chain. The objective is to identify this weakest link and keep on strengthening it to make organization stronger and stronger and make it grow steadily. Kaizen also uses Mura as a powerful improvement tool. He prefers to use discrepancy instead of inconsistency. Discrepancy can be identified in areas like method, time, facilities, manufacturing aids, materials, production volume, inventory, place etc. Once this discrepancy is identified, it is analyzed, and solution is found out to eliminate the discrepancy, leading to culture of continuous improvement. Mura calls for minimum deviation between the best and the worst product or service. Minimizing the range of deviation and minimizing the standard deviation in the statistical process control. 3. Muda. Muda means waste. Waste is any activity that does not add value. Duran has called all the activities that do not add value the cost of poor quality, COPQ. Taichi Ono of Toyota Motor Company has identified 7 mudas or 7 wastes, which have been further modified to 9 mudas. Elimination of these wastes reduces the cost of production, enhances productivity, reduces cycle time and leads to better customer satisfaction. 1. Waste from overproduction. Normally, the tendency of an organization is always to overproduce to ensure no shortage of material in the market under any circumstance, or to fill up the idle plant capacity during lean period. In today's dynamic environments, products and services have shorter life cycle. If a product is in inventory for a long time, it may become obsolete in the market. It also may occupy plant capacity for products that are already there in the stock, whereas some of the products for which customers are waiting cannot be produced due to this blockage of capacity. It leads to piling up of excess inventory, occupying more storage space, excessive material handling cost, interest cost on unsold stock etc. 2. Waste due to waiting time. Any time wasted in waiting for the parts to arrive due to improper line balancing, or waiting for job instructions due to improper planning. These waiting time has to be identified and eliminated from the system. 3. Waste due to unwarranted transportation. Unwarranted transportation happens due to unplanned and improper plant layout, leading to parts/materials being moved